KOJRO, and this time we are going to continue with the Retro Chip Tester Pro. And I got this package from Distrelec with the ULN 2003A chips, and I put one in my Retro Chip Tester. And this package actually arrived about 1 week ago, but I had to go to a business trip. And around me now you can see the beautiful town of Longyearbyen in Svalbard, Spitsbergen. And the city is in its most beautiful period this time of the year, and this picture is taken about 9:30 or something in the evening. And it's freezing cold in about minus 19 degrees Celsius. So this time we are going to finish the build, really just putting in the chip, and I'm going to do some additional fault finding because I did get an error last time, and I suppose that was because of this chip was not in, but I do have to make a new test afterwards. So let's just dig into that. Yes, and here are our Mini Pro programmer, and here I have the bag with goodies that I got from Distrelec. Back in the day, the packages from Elfa, as they was called back in the day, was my favorite kind of gadgets. There are some variations of this chip and also some other chips that's pin compatible, but this is the original ULN 2003A that was stated in the boom. I couldn't find my chip pin straightener for 300 DIL chip, so I just have to make do with pushing the pins down to the mat to make them even. Yeah, and then the chip fits straight into the socket, and then we just have to connect this to DC power. And I do follow the recommendations. I use about 7 volt or 6.9 I think from my DC bench power supply to fire this up. That should be so low voltage that we don't require a heatsink on anything. Yeah, and then I try to remember where I hit the diagnostic or self-test mode. So we just do a self-test of the unit to see if the fault is still on when we have put the chip in. And it still fails, and it gives us a clue here. It says that is VSS, that is the culprit that fails the test. So I do think I will start with looking for solder bridges and clean out the backside of the board. I did not clean off the flux last time, so I'm going to do that throughout now anyway. But first, a manual inspection of the board. First I check for the obvious faults, like transistors that's turned the wrong way, or that I have misplaced some transistors or resistors, among others. And it's very easy on this board because there are so many of each value and they're standing close by every one of them. But everything seems to be okay. Of course there can be some hidden fault even on this side, but I can't spot any right away. Yeah, I see some points here where I could go over again with the soldering iron. Nothing particularly bad, but there always are some spots that's not bright enough, or some vias that can be filled better. And that's mostly common when you have very thin component wires and big holes. But I will just take away the power supply, daughter card and the display, and start washing down this board and get rid of all the gunk that's left from the soldering process. And I've seen a lot of guys on YouTube, when they clean away the rosin rests on the soldering process, they just brush this away. They don't do anything to actually remove it from the PCB. it don't evaporate with the isopropanol, so there will be this residue still left on the board if you don't take some paper or some other things to actually try to remove the gunk. And the isopropanol does a terrific job with loosening it up, but it won't remove it. So when most of the gunk removed, I'm going to do some soldering touch-up and maybe apply some solder on a few joints that looks to be a bit thin. And here I actually discovered and removed a soldering bridge between two of the pin header pins on this socket here. Yeah, just some final touching, some scraping and some soldering, and I think we are ready to make a new test. There always are some cases that you won't notice at first, so you have to take a second glance, and I'm glad we did this on this board because there was several things that could cause this kind of failure. Yeah, then we put back the display module and the power supply, and we do another test. After we plug in the power, I fiddle a bit with the menus before I enter the self-test modus. Yeah, and then the test passed with flying colors after we have cleaned up the board and removed the solder bridges and some leftover solder residue. I do plan to make a stand or a case or something for this tester, but until then I just mount some standoffs that could keep this away from the board and avoid shorting out if there are something beneath the board. And this is some leftover parts from PCs and some other standoffs that I have laying in my parts bin. The plan is to put one in each corner and one in the middle to support the socket when I take in and out chips. And I also need some beneath the display to keep the display stable in the socket. This is how the README file of the Retro Chip Tested Pro states that the standoffs and hex spacers, they call it, should be mounted. And they say that the feet should be 5 to 10 millimeter long, and of course you have to have them so long that you don't short out anything beneath the board. And my is, I think, 8 millimeter long or something. I do have some 6 millimeters that I can exchange these with if I place it on a plexi board or something. And here they state that the spacers for the display should be 11 millimeters long, and mine was 10 millimeters long, and then I added the hex nut on this, and the hex nut is a little bit less than 2 millimeters, so they probably are about 11.7 something millimeters long, and there are a small gap in the connector in the back, so they could have been a bit shorter, but the connector fits nicely, so it will be a good fit. And they say that it's important that you use 3 millimeter spacers on this. A little bit above 3 millimeter goes fine, but if you use 4 millimeter or something that's more than 3, like the special PC screws, I do think it will fit the board, but it won't fit the display. So that's not something you should get yourself into. So use 3 millimeter, And he said that you should use this of nylon or plastic, but there are good clearance on every part here, so it's no problem with using this of brass as I have used. And he has placed standoffs in every place here, and I probably should have placed one more under the switches here. So I will look into that later, but I have to go into the shed and find one more of these brass ones. Yeah, under the display, my standoffs that I have here is about 10 millimeters in height, and they will be a bit low. So I am planning to add nut on these to make them a bit higher. But first I just check that this goes into the feet that I have, and then I put on the nut, and it's an ordinary hex nut 3 millimeter, and I do it on all the standoffs for the display, and it will be about a little less than 12 millimeter when you connect this. And the standoffs that I have has the 3 millimeter bolt standing down, so I'm just putting on a washer and a hex nut to fasten this. And as you can see, there is no leads in close proximity to this, so it's no problem to use these wide washers. Yeah, and then the display should just fit fine on this. You can see there is a bit of space behind here, but it's good contact, so it's no problem. And here I use ordinary 3 millimeter screw and just fasten it down. Yes, like so. And then I need to do something to support this in the middle at least. I do want to put this in a more permanent stand or something later, but first I'm just going to make something that I can test this in a secure and good manner. Yeah, and since the board is a bit bent down in the middle, I'm just going to use a hex standoff that is a bit shorter, and I use a screw as a feet on this so I can adjust the length so it will be stable on the board. Yeah, so before I can get this fixed on something permanent, I can just cheat and adjust this screw to make it stable and keep the board as bent as it is. Yeah, just like so, and then we have the board stable and can get on with our testing. Yeah, this might not look as professional as it could be, but this will do just fine, and it will keep the board just from bending too much, and it will keep it off some leftover short circuit material. To make sure that we have not destroyed anything while we're doing this, we just run another test. Yeah, that went straight through, so then we are ready to test some other ships. And I do have some good ones and some bad ones in a mix here that we can use to test.
No.
What happened?
He hates bright lights.
Yeah, making those diodes so bright was not a wise choice, but until I get to fix that, I have to cover them up. Yeah, first we test some TTL logic chips, and this is a 74 LS16, that's a hex inverter with open collector outputs, and this is a known good chip as far as I know. Yeah, and it tests okay. And the next chip out, we actually try to fool the systems a bit, because that's a 7406. That's basically the same as a 7416, but the 7416 have a high voltage output. That means that you can drive higher voltages up to 30 volts, I think. And as you can see, that also tested okay. And this is leftover chip from a previous video. The next chip is a 74 LS 6408, and that's an AND gate, 4 AND gates in one chip. And this is also from a previous video where I tested the TL088 mini programmer. On the display you can see that it tests all the gates individually, but you can't see the truth table as you can on the mini programmer. The next chip is actually from one of the C64 board repairs, and this is a 74257. And this chip was desoldered because a solder blob was making it appear that it was shorted on the board. And this multiplexer chip, there actually are 2 of them on a C64, and I changed both of them on this board. So the next chip we will be testing is the evil twin of this one. And here you can see what happens when we test a known bad chip. Commodore sometimes tried to save a few extra bucks and made their own chips, and they did not have very good quality. So the MOS 7708 is the same as the 257. The error message is a bit cryptic. Maybe it's a part of the truth table, I'm not sure, but this is a part that's much easier on the Mini Pro programmer to see what actually fails. And the next chip I'm going to test is a bit controversial. It's a 4066 analog switch, and it's a CMOS device, and it does not work in a C64, but it tests okay in the Mini Pro programmer. But I'm very curious to what this tester will say about this chip. The 4066 is an analog switch. And on the Commodore 64 it's used to switch in the pot X and pot Y leads to the SID chip, where you actually have one input for each joystick port, and they are multiplexed down to these 2 leads here. And this is done via the keyboard decoding, actually that's happening via the U1 CIA chip. And here it acts as an analog switch, a complete analog switch. And that means if there are some extra resistance or something here, there will be some deviance on this pot X and Y. It will actually read as a higher resistance than it should be. And that is a minor fault, because you often have some adjustment on the paddles or analog inputs on the C64, but it will be a faulty readout eventually if this resistance is too high, and you won't be able to max out the potentiometer in the high ohm direction. But the other 4066 that's in a C64 is actually this one. And this stands as an analog switch, of course, but it's actually switching digital signals, because it switches in and out the data bits for the color RAM. So the color RAM chip on the C64 is 4 bits, and these 4 bits are also used to read other data to the VIC2 chip, and this chip handles to disconnect the color RAM bus from the VIC2 chip. And if this chip fails with a too high resistance, it will actually make low read as a high if the resistance is high enough. And that is probably why this 4066 is reading bad or is not working in any position in a C64, but it actually working in the tests, because the tolerance for the resistance is different. And as you can see, this tester also tests this to be totally okay, even though it doesn't work in a C64. The ink marks hide the producer of these chips, but I have a preference for Philips or Toshiba 4066 chips, as I have never had any of those to fail. Yeah, but now let us test some memory, and we first test the 4164 chips, that's 64K by 1 bit. And we first try with a chip that fails in a C64 and also fails in the other memory tester I have. And as you can see, the algorithm says that the chip is not recognized at all as a 4164 chip. That means that I actually can't get what is faulty with this chip. I just know that it does not work, and that's no way to satisfy my curiosity, at least when I do fault finding on electronics. Here I have sped up the playback so that the testing actually appears much faster than in real life. I think it's 5 times. It's testing different patterns, and it also do a random test to write and read back the contents. But of course, long time testing of refresh, it does not test. And this only express ship makes the test with flying colors. And we will try to test another ship, and this time it's the 4 bits by 64 variant. And as the different producers of memory chip have similar names but not exact the same on compatible chips, or mostly compatible chips, you often have to look this up. But this chip is a 4464 in this tester, and not a 41464 as most of the chips I've seen in the Commodore 64s are named. And this is the faulty chip from our shortboard video, and it also tested as not recognizable and asked us to insert a new one, and we have done that now, and we are again doing the 5 times speed on the testing process, so you don't have to wait and just look at the blinking lights. And as this tests all 4 bits, this actually is a kind of a different test pattern, it seems like. But refresh and the technology behind this should be about the same as in the 1-bit chip. And this particular chip is from the same batch that I already have proved one chip to be working, as I used this to replace the bad one in the shortboard video. Yeah, and this test passed again with flying colors. Yeah, I will use this tester regularly now to test chips, so we will be seeing this a lot more in future videos. Yeah, so this concludes our build of the Retro Chip Tester Pro. It has actually been a delight to build this. I'm very satisfied with the kit. I get it pre-programmed. I ordered the parts. I've done some slight modifications. I used the larger relays and so on, but mostly stick to the original drawings. I also changed some of the diodes to have different lights on the power rails, but no other big deal. And I'm quite satisfied with the build. It does meet my expectations, but I do think that, yeah, some of the algorithms and some of the other things don't necessarily mean that this tester is much better than the others. But the range of chips and different logic chips and different series of logic and special driver chips and stuff that you can test, this makes this stand out from all the rest of the devices that I actually have when it comes to this. And also its easy ability to read out the contents of all ROM chips, and that you can make adapters to do cartridges and other stuff. It's simply quite amazing. So I'm probably going to build some of the different adapters to fit into this. And I also have a card reader, so I might get back to this when this is finished. But I will be featuring this in future videos when I do repairs and need to test chips. So I will use this as my first go-to tester, and I will use the Mini Pro as a backup and second opinion tester in some cases. So we might do some comparisons in the future. So that really is it. I think they've done a terrific job on this, and the 8-Bit Museum can be proud of this design, that's for sure. So, thanks for watching, and my next video, I've not decided on the topic yet, so that might be a surprise, both to me and hopefully to you. See you in the next one. Thanks for watching. Please hit like and subscribe if you like my videos.